Hey there guys, here we are looking at integration AS level maths exam questions involving area under a curve. These questions are quite tricky. We have a 4, 5, 8 and 10 mark question, so pretty big and tricky. Let's go. Okay then, first up, a curve has equation y equals 6x squared and 8 over x squared, and is sketched below for x greater than 0. Find the area of the region bounded between the curve, the x-axis, and the lines x equals a and x equals 2a, where a is greater than 0, giving your answer in terms of a. Okay, so that area is the integral of the curve between the two limits of a and 2a. So we need to integrate the curve. So the area is the integral between a and 2a of 6x squared add 8 over x squared. Now that we're going to write as 8x to the minus 2. And that is with respect to x. Okay, so now in square brackets, 6, okay, now 6x squared integrates to 6x cubed over 3, so that's 2x cubed. Now, 8x to the minus 2 integrates to 8x to the minus 1 divided by minus 1. So that's going to give us minus 8x to the minus 1. And that's between a and 2a. Okay, so now we plug in the limits. So when x is 2a, we're going to get 2 times 2a cubed. 2a cubed is 8a cubed, so we have 16a cubed. And minus 8x to the minus 1 means minus 8 over 2a. So that's minus 4 over a. And then we subtract what we get when we put a in. So there we're going to have 2a cubed and then minus 8 over a. Okay, now altogether, we then have 16a cubed minus 2a cubed minus 4 over a. And then minus 8 over a, so add 8 over a. So finally we have 14a cubed add 8 over, no, sorry, add 4 over A. Done. Key number 2. A curve has equation y equals 2 over x root x. The region enclosed by the curve, the x-axis, and the lines x equals 1 and x equals a has area of 3 units. Given that a is greater than 1, find the value of a. Okay, so we know that area is the integral of the curve between the two limits. So let's integrate. So 2 over x root x is 2 over x to the 3 halves, or 2x to the minus 3 halves. So we want to integrate 2x to the minus 3 halves with respect to x. And we are doing it between 1 and a. Now we also know that is equal to 3. Okay, now we're just going to deal with the left hand side. So, x to the minus 3 halves integrates up to x to the minus 1 half. And then we divide by the new power. So 2 divided by minus 1 half is minus 4. So we have minus 4x to the minus 1 half between 1 and 8. Okay, now let's plug in our limits. So when we put a in, we're going to get minus 4 over root a and then we subtract what we get when we put 1 in. So minus, so that's just going to be minus 4. Okay, now then, we know that that has to equal 3. Okay, so now we can say that minus 4 over root a minus minus 4, so add 4 is equal to 3. Okay, now we can subtract 3 and add 4 over root a, and we will get 1 is 4 over root a multiplied through by root a, so root a is 4, and then square both sides, a is 16. Done. Okay then, number 3. So this time we have a quadratic which cuts the axes at minus 1, 0, 0, minus 4, and 2, 0. And we want to find the area of the finite region between the curve and the x-axis. So that is, that region in there. So what do we need to do? We need to integrate the curve between the limits. But there's a problem, we don't know the equation of the curve. So we need to find that first. So it's a quadratic, so it's of the form y equals ax squared add bx add c. Now we know c because it's the y-intercept, so straight away we can start to say y is ax squared add bx minus 4. Now to find a and b, we need to plonk in the other two coordinate points. So minus 1, 0 and 2, 0. So minus 1, 0 would tell us that a minus b minus 4 is equal to 0 and 2, 0 is going to tell us that 4a add 2b minus 4 is equal to 0. Okay, so now it's a game of simultaneous equations. So if we call these 1 and 2, I'm going to multiply number 1 by 2 to get minus 2b. So I'm going to have 2a minus 2b minus 8 is 0. And I'm going to call that number 3. Okay, then I can now get rid of the b's by doing number 2 add number 3. So I'm going to have 6a. The b's cancel, and then we got minus 4 add minus 8, so that's minus 12 is equal to 0. So a is 2. From that we can unplug that in. So I'm going to put it in the top equation. So we would then have 2 minus b minus 4 is equal to 0. So that's minus 2 minus b is 0. So b is minus 2. So now we know then that y is 2x squared minus 2x minus 4. Okay, so now we know the equation of the curve. We know the area is the integral of the curve between the two limits. Now, there is something to look out for here. Because the area is below the x-axis, it's going to come out as negative. But the area itself is positive because it's a physical quantity. So, let's integrate. And we are doing it between -1 and 2. Okay, so we're going to get 2x cubed over 3 minus x squared minus 4x. Okay, now plug in the limits. So, when x is 2, we are going to get 16 thirds minus 4 minus 8, and then we subtract what we get when x is -1. So, minus, now we're going to get minus 2 thirds, and then we're going to get minus 1, and then minus 4 times -1 is plus 4. Now, be very, very careful with the signs. We should get -9. So, as I said, it came out negative, but the area itself is 9. And then number 4, so, 10 marker. So the curve C as equation y is 32 over x squared at 3x minus 8, 4x greater than 0. The point P46 lies on C. The line L is the normal to C at point P. The region R, shown shaded, is bounded by the line L, the curve C, the line X equals 2, and the x-axis. Our job is to show the sheet area is 46 units. Alright, 10 marks. So, the first thing we're going to do is split this area. So we have a region under the curve, and then a triangle. So I'm going to call these two areas A1 and A2. Now, we know how to find areas under curves. We integrate. So, let's find A1 first. So, if we rewrite the equation for C, we get y is 32x to the minus 2 and 3x minus 8. Okay, now we know A1 is the integral between 2 and 4 of the curve with respect to x. So, the integral is going to be, now x to the minus 2 integrates to x to the minus 1, and then we divide by minus 1. So we get minus 32 over x. Three x integrates to 3x squared over 2. And then minus 8 becomes minus 8x. Okay, now let's stick in the limits. So, when x is 4, we get minus 32 over 4, which is minus 8. 3x squared over 2 is 48 over 2, which is 24. And then minus 8 times 4 is minus 32. Okay, and then we put in 2. So we subtract what we get when x is 2. So minus 32 over 2 is minus 16. 3x squared over 2 is going to be 12 over 2, so 6. And then we have minus 16. Okay, so that gives us minus 16 minus 26, which gives us 10. So A1 is 10. So now we need to find A2. Okay, now A2 is the area of a triangle. Now we know the height of the triangle is 6, the y coordinate of P, but we don't know the base. So all we need is the x-intercept of the line L. So we need to find the equation of L, which remember is the normal to the curve C at P. So now we're using differentiation. Now if you haven't done them already, I have a whole playlist on differentiation exam questions. Okay, so we need to differentiate the curve to get the gradient at P. So dy by dx is going to be minus 64 x to the minus 3, which we can write as minus 64 over x cubed. And then plus 3. Now at P, x is 4. So dy by dx is going to be minus 64 over 64, add 3. So that's minus 1, add 3, which is 2. Now, that's the gradient of the curve at B. So the gradient of the normal is the negative reciprocal. So, I like to call my normal gradients M with a little n. So that's going to be minus 1/2. Okay, now we can start to put L together now. We now know Y is minus 1/2 x add C. Now we know when x is 4, y is 6. So that gives us 6 equals minus 2 add C. So C is 8. So finally, the normal, or the line L, is y is minus 1/2 x add 8. Now remember, what we're trying to find is the x-intercept. So, on the x-axis, y is 0. So we can set y equal to 0 and solve for x. So we get 0 is minus 1/2 x add 8. Now that tells us then x is 16. Okay, so now go back to the diagram. We now know then that the x-intercept is 16, 0. Now, the actual length of the triangle goes from x equals 4 to x equals 16. So the basic length is 12. Now this means then that A2 is 12 times 6 over 2. Which is 36. So then finally R is 10 add 36, which is indeed 46. Boom. Guys, that's it for integration for now at AS. Let me know what you want to see next in the comments down below. For now, take it easy, take care.